Hello, integrated science students. Right now, I'm going to show you where I filmed this lab demonstration and kind of break it down for you as you think and observe and answering these questions in this Explore activity. So we've been talking about plate tectonics. So in this activity, it's really, really good where we use a hard-boiled egg. As I've already set this up for you, I give you the hard-boiled egg. You write down the egg layers, which is the shell, the egg white, and the egg yolk. You document that, and then think of, in the event of how we compare that to the Earth. Well, the shell is to the crust, which we are on. The egg white, which is in the middle, is like the mantle. And then, of course, the solid center of the egg is the yolk, and that's like the core to the Earth. And then I wanted you to see the observations for the temperatures in each layers, the state of matter. And what you will notice is they all range. And what they range in is the temperature is more warmer towards the core, and it's cooler as it goes to the crust. Same for density. What happens to density? Objects that are more dense are going to float to the top, okay, as opposed to the center. And then, of course, the state of matter changes. If it's really, really warm in the center, we're talking about a liquid layer as compared to a solid layer that's on the outside. So I'm giving you these questions to think about. And with the hard-boiled egg, the next step that I wanted students to take is take a Sharpie and draw however you like the layers, as you see right here, 9 plates. And you can make them in different sizes, different shapes. You determine that. 9 plates that you will draw out using a Sharpie on your hard-boiled egg. And then as you draw those lines, I take you to use a dissection kit, which I use, and you make perforated lines, tracing your lines as if you're going to cut and remove the plates without snapping your egg in two or anything. So it's hard boiled, so that makes it a little bit easier. But still, when we're using sharps, you want to be careful not to poke yourself and bloodborne pathogens and those things. And as you get closer, I want you to remove the plates one by one the best you can. As you remove the plates, you're going to observe what happens. Is it perfect? So right here, you notice, is it exactly the way that you drew it? Does some of it break off? What happens? So right here is an example of 9 plates that were removed from my egg. And notice 1, 2, 3, 4, 5, 6, 7, 8, 9. I lost some pieces along the way. So the next part is trying to flatten them out on a paper towel because it's going to be a little wet from moisture and condensation and those things. And then I instruct you, as you'll see if you can put them back together the way that they were. Is it exactly the way it was before? What do you notice? Well, obviously there's some gaps. We lost some along the way. And what does that mimic? What does that mimic? It doesn't go together perfectly. We lost some along the way. That means over time, this changes. And even though we've got the pieces right here as a whole, it doesn't connect the way that it used to, just like we observe the changes on our planet. If the plates are constantly moving, it's going to obviously not come together exactly the way it was before, like a puzzle. But that's what you're thinking about, okay? So now answer this next question below and rewatch this video if you want to see this again. Thank you. Take care and have a good day.